Happy Monday.
Happy Monday. How's it going, Joe?
Good, good. Good to see you.
Good to see you too. Yeah.
Nice.
Got away for a bit this weekend, it sounds like.
Yeah, I've got away for a bit. It's kind of nice.
Nice.
But we're back. And also for the audience out there, we're also going to be making some changes to Monday morning data chat. We're going live Monday mornings at 9 a.m. Mountain Time. We're going to be streaming the show live on LinkedIn Live and YouTube Live. So feel free to join us. We like the interactive, Q&A and audience discussions and stuff. So we figured, Monday morning data chat lends itself really well to live listener questions and comments. So yeah, happy everyone can join. And also we'll make this available as a recording, YouTube Live, LinkedIn Live, as well as a podcast platform of your choice. So awesome. You want to kick off today's topic?
Yeah, today we're going to be talking about what software engineering skills a data engineer should have, which I think is on the, it's the title of the live stream as well. Is that correct?
Yeah, it is.
Yeah, I think we both believe that there's a lot of confusion around this area. So for example, some people equate data engineering with software development, which we think is not quite right. At the same time, data engineering has this very important component of software development. So actually more software engineering. And so we wanted to talk about how software engineering fits into data engineering and how the evolution has happened over the last couple of years.
Yeah, cool. Yeah, so what's happened over the last few years?
Well, okay, so I think we've both been in data for a bit, and one of the big changes is that during the big data era, people did things like write MapReduce jobs, right? And for the most part, people aren't doing that anymore. So this was like a very kind of hardcore, low-level version of software engineering that you had to do to handle large data sets, and it's just not a significant factor anymore. But that doesn't mean that software development itself or software engineering has gone away as part of the discipline. It's just that it's moved up in levels of abstraction for the most part.
Yeah, that's right. Yeah, I think if you kind of look at the history of things, there's always been some amount of like customization in code, and it's interesting too, because I think that through the early phases of maybe the before times data engineering, where you had a ETL developer or BI engineer, like a lot of these were using maybe SIS packages or something even more rudimentary, Informatica, very monolithic tools. Some coding involved, but not too much. And then I think the era of sort of the mid 2000s through the mid 2010s really ushered in a sense of like hardcore software engineering because of the rise of big data systems like Hadoop and related systems like that. So
yeah. It's interesting to see how like big data frameworks have evolved in the last several years. First of all, there's been a move away from a lot of these more traditional Hadoop projects. I think for the most part, Pig, for example, is mostly in maintenance mode. Some companies are still using it, but if they're using it, it's not generally because they're adopting it new. It's because they were using it before and they already have a code base. There's been a shift toward frameworks like Spark, and even with Spark, the nature of development in Spark has changed pretty dramatically and become more abstract.
Now, how do you mean?
Well, so it used to be that you had to worry about RDDs, like redundant, these low-level data.
Resilient data, distributed data sets.
Yeah, exactly. And now you have data frames, and data frames in Spark now behave a lot like they do in Python Pandas and in R. Like they're just easier objects to work with, and there's not as much that you have to think about.
Mm-hmm. Yeah. I would say too, what sort of pushed that along though in Spark? Because the RDD for a few years was the first class citizen, but then it got sort of taken over by data frames. But what do you think pushed that?
It seems like in general in data, there's just been a move toward more abstraction. I think the focus has shifted toward data engineering productivity as opposed to like really being the low-level guts of the system.
Interesting.
Yeah, there's just this understanding that that's your key bottleneck, right? The bottleneck is not necessarily your system or your software. It's like the people developing it. And so if you can make them more efficient, make it easier for software engineers, data engineers to do their jobs, then a lot more is going to get done.
Yeah, I would say, yeah. Yeah, I mean, Todd's right. Even Spark is different these days than it was 4 years ago. That's for sure. Yeah. I mean, I remember when using Spark when it first came out. Was it 2014, I think it was. It's like, this is like the coolest thing. But yeah, it's changed a lot. I guess, what's your argument though? Do you think people should use Spark, or are there all other alternatives, or do you want to start a holy war this morning?
I think that they should. So one of my opinions is that the reasons for using Spark have changed so much. So I would say when Spark first came out, the emphasis was on the fact that Spark was a big data tool. Well, the reality now is that there are all kinds of off-the-shelf big data tools, including cloud data warehouses that can handle petabytes. Like, you don't need Spark to do big data. What Spark is useful for is low level, if you need to get deeper into the data than like SQL will allow you to do. If you need more of a general purpose data frame paradigm, as opposed to a SQL paradigm, then Spark becomes really useful.
Yeah.
And the nice thing about Spark is that it does cross over, right? You could still use SQL and combine it with lower level operations inside of data frames, more programmability. You could potentially write your own packages and integrate those into Spark if you want to get really into the nitty gritty, which sometimes you do if you have a specialized application. But yeah, I think just the reasons behind Spark have really changed in the motivations.
It seems to have, yeah, for sure. I mean, there's always been tools that you could use to query data, I think, in a more traditional sense. You've always had Hive, Dremel, and so forth, right? But I don't think that the number of people I see using those tools today, maybe Hive, just because I think it had a good footprint, but I mean, it's rapidly going away, I think, in place of, again, like you point out, cloud data warehouses.
Like
even in Presto's another one. I mean, they built out Facebook to replace Hive. So, and I think the other part of that is to more appropriate solutions too. You got, if you need real-time analytics, use Druid. I mean, so I don't know. But yeah, it seems like software engineering, though, I would say in general, I don't think it's going anywhere per se, but I would say that the footprint of it is changing just because you don't need to have, there's just so many more options out there that are, I guess, simpler than writing custom code. I think we're of the opinion, keep writing custom code, but focus on the areas that really have an outsized impact. Making data pipelines that just simply pipe data from point A to B. I mean, there's a ton of open source products you can choose from that pretty much do this out of the box, like Airbyte, for example. If you want to go open source Meltano, if you want to, buy something, Fivetran's great, Stitch is great, Matillion's great. So there's a ton of options there. I don't want to say it's, you're living in the golden age of like data connectors, especially these days. There's no shortage of tools. So
yeah, and the point is that if you only have the capability of using something like a Matillion is great, but like if you're limited and can only use a graphical interface to do data engineering, then you're probably not a full data engineer. So a data engineer has that ability plus the ability to write custom solutions as the need arises. So they can use a Fivetran or a Meltano or whatever built-in connector, but then once they hit a wall where there's no connector for a particular API, they can sit down and write the code to connect to that API.
Yeah, that's a good point. We got a question here from Mark Keeling. What courses or books do we recommend to learn the skills from software engineering that are relevant to data engineering?
Oh, that's a good question. You must have some thoughts on this. Yeah,
I think a lot of the classic books from software engineering, I think, are directly related to data engineering. So books that come to mind, Pragmatic Programmer, still one of the best books, I think, on programming in general. Just get it and read it. What else? There's domain-driven design. I think anything related to that would be good to know. I mean, we're going to cover this in our book too, I think, for architectural patterns, but I don't think that's going away. What else? Clean code. That tends to be a classic. I think that it's kind of fascinating because a lot of these books are written back in the 2000s or maybe even earlier, and they still hold their weight, I think, in terms of just best practices for software engineering. I'm pretty sure there's like a ton of others, but if I'm going to look at the classics that people still refer to, those come to mind. Courses, that's a good question. I don't know. Do you have any thoughts on?
Actually, I was thinking about, books are great, but there are a lot of really great, for data engineering, I almost tend to lean more toward blog posts. Like the Netflix engineering blog is fantastic because it does a really good job of taking classic software engineering principles and applying them in the domain and talking about how Netflix thinks about data, for example, and how they think about a really complex heterogeneous environment and things like version control and discovery and lineage and metadata and all these really hard problems of data engineering. They put all those things in context. And so if you combine books with that domain-specific knowledge, I think that in itself can be a really great course.
Yeah, and I've been looking through some books I have on my shelf. I'm moving right now, so I got books kind of scattered everywhere. But I mean, there's an old goodie, Growing Object-Oriented Software Guided by Tests, riveting title. I mean, I was thumbing through this the other day, and it actually still holds a lot of weight. I mean, it's written in Java, like 4 or something, but that's an old school book that I right. A DevOps handbook, I would say this is just a really good book in general. It's not necessarily software engineering related, but I would say this is still one of the better books for getting a handle on some of the practices you'll need to learn for data engineering. You'll hear the term DevOps thrown around, or data ops, sorry. And it's just basically DevOps applied to data when you get down to it. So I would say learn these skills, learn proper programming skills from the books we mentioned. Pragmatic Programmer, I'd say being the top one, just because that's still a valuable book. I mean, I still thumb through it. Now I have it on my Kindle actually, but I'll read through it, and I still think it's got a lot of great advice. Just how do you think about software projects? How do you think about the process of crafting code? Right, like this is pretty cool. I think it's something that's really underrated in data engineering, especially. It's kind of funny because Matt and I were talking about this before about just like what is it? Looking through differences of software engineering and software development, and it's kind of funny. Maybe we can show some of these links here real quick, but it's because I kind of feel like there's certain engineering principles that if you're going to call yourself an engineer, you should in other fields, for example. Like mechanical engineering, that's actually an engineering field. Like there are principles. You have to take a fundamentals of engineering exam, for example, to become or used to back when I was an ME student. But if we share the screen real quick, I just want to kind of highlight maybe some just general. Because I think we're going to see this more in software engineering or data engineering as we kind of go about just the distinctions of different roles. So this article comes up, I think it's a top 2 article in LinkedIn if you search for software developer versus software engineer. But it goes through these distinctions, some of which I think we agree with, some of which we're kind of scratching our heads at, like a programmer, a developer, an engineer, for example.
But it's a matter of rigor, right? Fundamentally, I think that's what we would argue. So, for example, there are various ways of orchestrating data processes. And so if you're just writing scripts, that's one level of rigor. Going into an orchestration framework is more of an engineering approach. And I think the more you apply principles of reliability and monitoring and data ops, the more you're in the engineering realm. Certainly like hacking on data on a laptop is actually still part of data engineering. Like it's still something you have to do. You have to explore and you have to look for problems. But the engineering part is when you turn that into something production and reliable that sends alerts and that can run reliably and support businesses without just falling over one day.
Mm-hmm. Yeah. I mean, I kind of equate it to building a bridge or something, right? Like you want an engineer helping you with this. A couple of freelance carpenters, it might not do the trick. Might, but depends on the bridge you're building. But yeah, I think maybe it's a level of rigor, application of engineering principles, and but in software engineering, right? This is a fairly new field, and I can't make an argument that there's defined software engineering principles from an engineering perspective. And we've done our homework on this. I mean, for the research that we're doing on our book, I mean, we dug pretty deep on this, and there's if there are standards, I don't think they're universally applied. So.
Yeah, it's an ongoing debate, I think. Should there be certifications for software engineering? Should there be more training for software engineers? And I don't think that debate has come to a conclusion yet. I mean, it's interesting because even computer science programs teach you certain parts of the software engineering domain, but others aren't covered extremely well, at least as far as I've seen. So for example, you might use version control. Hopefully you're using version control in your computer science program. You're probably not getting real deep into continuous deployment and all these other aspects of like DevOps that really make software systems work well and make deployment process work well too.
Yeah. So, I mean, we're having this discussion actually in Harpreet's office hours on Friday about, because our buddy Mark Freeman wrote an article about aspiring data scientists, and maybe whether or not people should use the word aspiring. And then I think it turned into a discussion on roles in general. Like, what is a data scientist? Should we actually have standards in titles? And I kind of go back and forth in this. On one hand, I think maybe there should be. On the other hand, I'm not a fan of gatekeeping. On the other hand, I do think the title should be explicit and mean what they say and say what they mean. If everyone's a data scientist, and I guess nobody's a data scientist, and if everyone's a data engineer, then nobody's a data engineer. At the same time, if you go back to the article we were looking at, it would be odd to have like the terms like data programmer and data developer if you were to take the strict software naming convention and apply it to data engineering. So I think the jury's out, but title-wise, I think we're of the opinion, and we write this in our book, that a data engineer should be applying the principles of engineering and software engineering at the rigor that would be expected of a software engineer. And we actually cover this also as software engineering being one of the undercurrents of data engineering.
Yeah, it means you should be doing things like version control and potentially automated deployment. And you should be thinking about failure modes and SLAs, like how reliable does your data system need to be? What happens when it falls over? How do you make sure that it's not going to cause catastrophe, similar to like a bridge collapsing or some other horrific occurrence in the natural world?
Right. I got a question here from Sunil Guglani, I think I'm pronouncing your name correctly. It shows up in LinkedIn user here, but what is your opinion on Golang? Is it software engineering lang or data science? And I think before we get to this, Todd Hansman, what's up, Todd? Golang is great for data, but more limited in the number of community posts and libraries at Python or Java. So you may have to do more self-lifting. I totally agree with this sentiment.
Yeah.
I'm not a Go person myself, so I don't really have a dog in this fight. I can say from, I think, the perspective of just the number of tools out there that would require you to know Go, the libraries, I think it's far less than what Todd's indicating, which is Python and Java are sort of the king of the hill here.
Yeah, and there are people really advocating for Go as a data science and data engineering language. Friend Mariah Peterson is really pushing this, and I think the evolution will continue. And what is it? Are generics part of Go now, or still in beta? But like generics are going to make a big difference in Go. Yeah. That was a problem for a long time. Having that greater flexibility is kind of a thing you need for data. Yeah, so I'll be really interested to watch this development because, I still think for the moment, maybe Python is the #1 data engineering language just because it's a controller and glue language. And like you said, JVM languages are still all over the place, especially Java, but like a lot of Scala inside Spark. But Go really could start to grab more mind share in the data engineering world.
I think so too. Python's a great language. I've been writing in Python for a long time. I helped start a very popular Python meetup in the area, right? But at the same time, I think Python is kind of a crappy language for a lot of reasons.
In certain ways.
It sucks at performance. There's no way around it.
The interpreter lock, right?
Right, the GIL is the #1 issue that Python has, and people are making attempts to do the GILectomy, but when it happens, I guess.
Yeah.
It's a good language. I think it's some Pythonistas are like to say it's the second best language at everything, and it's a great language. But if you want performance, something like Go, Rust, maybe even Julia would be probably more appropriate. But again, now you're going to contend with lack of popularity, right? Now you're going off of just sort of the long tail of libraries, just because when something's popular, something becomes more popular. That's kind of how it is. And whether or not you want to say that Python is the Kardashian of the programming languages, might be up for debate.
I don't know where we're going to take that, but yeah.
It's got some utility, unlike some celebs, but I do think that it's. I've run into the brick wall of Python performance on projects, and it is what it is, and you're not getting around it. You can cheat and try and do distributed systems with it, using Dask or Spark, but it doesn't solve the fundamental issue that Python, it just isn't. It's not going to be as performant as things like Go or even a JVM language or Rust, which I'm fascinated by Rust actually. I have a note to go dork out on it whenever I actually have a chance to do that, but it's on my list for sure. So
yeah. And the interesting claim I've read about Go is that it was developed as a C++ replacement, but in practice, it's attracted a lot of Python programmers. And for the most part, it's a fairly simple, accessible language. It does have some interesting quirks. So one of those quirks is that concurrency is kind of native in Go, whereas in Python, it's tacked on, right? To the point where you have this global interpreter lock. You don't have true simultaneously. You don't have true multitasking in any sense. You really only have one thread at a time. But the trick with Go is Go routines are the standard kind of baseline execution unit. But even simple things, you have to I mess with Go a bit, and you have to tell the routine to stay open, or it will actually close before it does any work. There are these little quirky things that you completely take for granted in Python that you have to think about in Go. And yet, as it evolves and gets more popular, maybe that won't be such a big deal. Maybe we'll just all start thinking natively in terms of concurrency and Go routines and such things in the future.
I just realized I'm drinking from my Salt Lake City Python mug.
Oh, so. Yeah, perfect. I didn't even realize that was what
represent.
Yeah, that's a nice logo.
Actually, Koo, he has a good point here. If I look at the syntax, I want to prefer R rather than Python for data analyst stuff. It makes me more intuitive and cleaner. What's up, Koo? Koo is part of the Data Heretics and a good friend of mine. He's out of Singapore. So he's legit. And yeah, R is a good language too. Personally, I think the syntax makes my eyes bleed for R, but Koo, if it makes your life better, then
yeah. I mean, I feel like it's made a comeback too, because a couple of years ago you were hitting like this 4 GB memory limit or something, and it's only a few years back. And revisiting the language recently, as I've talked to people, it sounds like the R community has really fixed a lot of these issues that were preventing adoption a couple of years ago.
Mm-hmm. Yeah, it's getting to come back, and got a lot of friends on LinkedIn and other places, doing a lot of R training and selling great courses and stuff. And I think it's interesting because I kind of wrote R for Dead actually about probably what was it 2016 I think.
That's when I was kind of looking at it. And I'm like, well, there's some real problems with the community here. Yeah,
but it's a great language though. I mean, I still use it if I need to do stats. I don't reach for Python. I reach for R, and why is that? Because statistics in R as a first-class citizen, I can just kind of get in and do my thing. It's like a hand calculator, but like way cooler. So
everything in Pandas is more verbose, right? Like it does a lot of the same stuff, but it's just like these complex method calls. Whereas in R, it's just
and like loops. Loops is like a giant like cluster in R. At least for me, I don't know, because I'm used to like Python, where I just like really simple loops and stuff. But R is great. Like and again, I try and take the opinion. I don't really like to get into language wars. I crap on my own favorite languages often enough that maybe I'm just a self-conflicted human being or something.
Yeah. But you kind of have to be, right? And that's part of one of the central themes we're going to talk about a lot as we write is trade-offs. And a lot of engineering is about understanding trade-offs, right? There's no perfect tool. There's no perfect material. If you're in the physical engineering world, there's no perfect software engineering paradigm if you're in the data engineering world. It's all about picking the best tool for the job that will play nice with the other tools that you have to use.
See Jake. What's up, Jake Carter? How you doing, man? Start playing with Julia. It seems to be a great language. Yeah, it seems to be. I've had the same experience. Dorked around with it. It was. And by dorking around, like playing around with it for a couple hours, I thought it was great. I just want to see more libraries and stuff. That'd be cool. I mean, it's got the potential to take over. Take over such a strong term though, right? Because it makes it sound like it's kind of a zero-sum game, but I think it's got a lot of opportunity for sure.
Yeah, we'll see. I mean, I've kind of seen Julia waiting in the wings for a long time, so I think it's improved over time. But the question is it going to have its moment where it like really becomes a first-class citizen in the data science and data engineering world?
Who knows? Yeah. I mean, but then again, you saw this in like Python. I mean, in the early late 2000, when I got into Python, I mean, it was basically a toy language. I had computer science professors saying that, and other people in the industry saying, "Oh yeah, it's a toy language. It's interpreted. So how could you take it seriously?" Right. But then again, weird things happen, and now it's like a top language. So I don't know. Maybe that could happen with Julia too. I just think it really depends on the ecosystem and what developers want to gather around that. I mean, the killer thing for Python was just data becoming a thing, and it was just strange confluence of events that I don't know you can replicate that. You had data science taking off, deep learning, packages like pandas, but I would say it was deep learning and data science that really just pushed, and you can couple pandas in with data science, I suppose, but it was just a confluence of these events, the popularity of data science that really took off. I mean, data engineering frameworks didn't even really consider Python as an appropriate language. It was all Scala or Java. And then, guess what Spark's doing now? Guess what you can pip install? PySpark, right?
Yeah.
So,
I mean, I guess it's good to point out, this is probably a good time to point out that data scientists and data engineers use Python in very different ways. So if you're in data science, then the tendency is to use Python directly to get things done. So for example, use Pandas, transform some data right in Pandas. In data engineering, Python tends to be more of a controller language, like you're scripting some other framework that probably isn't written in Python, or an API language. So PySpark, Apache Beam, Python and those frameworks isn't generally doing the heavy lifting. Instead, it's just controlling what's going on behind the scenes, or like it's translated, the objects get translated into Java or Scala behind the scenes so that the heavy lifting can happen. But it becomes like this very convenient, almost universal interface to very powerful tools. And then you don't have the performance problems because Spark itself is doing the work. Python just issues the commands.
Yep. Yeah, exactly. Who also writes back, I heard it Julie since 2015. There's always been talk of a third language for data, but still waiting for it to be a thing. Yeah, me too.
Yeah. Go Julia, Rust. I mean, any of those could be the third language, right?
I'm pretty bullish on Rust, just for a lot of probably uneducated reasons, because I actually haven't played around with it too much. But something tells me, I don't know, maybe it's like my supposed sixth sense of where technology is going, which is total BS. But no, you get a certain smell after a while of whether something's going to be taken off, and I feel like Rust has its it feels like it has momentum, but who knows? That's like I said, that's all voodoo. Keaton, what's up? I hope I'm pronouncing your name right. What are 3 open source tools will you recommend to a data engineer once they're done with Python and SQL fundamentals?
Yeah, so I think one of the underappreciated parts, it depends on where you live in data engineering, but sometimes people are just coming into data engineering don't realize that one of your main jobs is not data processing, it's orchestration. In other words, it's controlling all these different jobs that run across different systems, especially in the cloud. Had you asked me a year ago, I would say go out and learn Airflow right away, because that's the dominant framework. I think there's a big shift happening in orchestration right now, and there may be a new top dog in the near future, probably Prefect or Dagster, but it's really not clear yet. I mean, Airflow has so much mind share, it really has the throne right now, and so it's going to be hard to displace it, but there are certain limitations of the way it was designed, and that's what these other frameworks aim to replace. So I would at least play around with a couple of orchestration frameworks, because again, that's going to be a big part of your job as a data engineer.
Yeah, I would say another one to keep an eye on is Airbyte.
Yep.
Yeah, that one's I think going to get a lot of traction. I think there's other projects that do kind of end-to-end data connections, but something tells me Airbyte's going to be the one you want to probably check out for data connections. So that's another open source tool. And like all open source products, there's the open source version, and then there's going to be the managed version from the people who do the open source. So yeah, that's another one. Git. Touche, Todd.
Yeah, for sure. Version control. There is a tendency in, I would say, especially in data science, but even in data engineering, to kind of be hacky about how you handle your code and not to version control. Really, really bad. Make sure you're version controlling. Make sure when you version control that you actually check into a repo, so that if someone steals your laptop at the airport, you can still get your code back.
Yeah, I mean, the only way you can make my eyes bleed even more than certain programming languages is not putting that programming language into Git. So it gets super important, and it's strange too. I think you're right. We definitely see this more on the data science end, but I do find data engineers that for some reason don't think about stuff like version control, which I would kind of be suspect of the like we were talking about the engineering term before. Todd hits on something very fundamental where it's version control is such a fundamental thing. I just think that's part of good engineering, right? Everything we do is version control, even the most minor stuff, just because it's what you do, right? And it's a habit you should get into. So, and there's new systems too for data version control. I would say go check some of those things out too. Other open source stuff. We can talk about trends we're seeing, I think, too. Look at writing the other day about how data engineering is becoming more enterprisey, and I think things are moving up the food chain, where you can start seeing more things that large enterprises used to do, maybe not so many small companies. Things like data governance, data quality, all this kind of blue shirt and khakis kind of office spacey type stuff. I say this in the best way possible because this stuff's cool, but this is going to become, I think, more and more part of data engineering. So great frameworks, maybe great expectations is one to go check out for data quality, data testing. That's going to be one. Y-Labs, yeah, exactly. And lots more. And I would say to follow into what Todd was saying with Git too, just knowing basically know your tools. And this isn't really an open source thing, but monitoring observability, this kind of stuff, operations basically. So again, it's not really open source, but you can find enough open source tools there to probably satisfy to your heart's content, because a lot of these kind of overlap with like software engineering tools, and we're kind of sticking to more data oriented tools. But yeah, and a lot of these things are covered in pragmatic, like learning your editor, debug editors, another one. So yeah, we covered more than the top three. But yeah, I would say knowing your editor is actually, I think, an underrated skill, and maybe we'll have a quick tip video on this sometime. There's
editors and IDEs, right?
Yeah.
Depends on what you prefer. And there's kind of a lot of crossover between editors and IDEs these days. But if you're doing a lot of Python programming, consider using an IDE, certainly.
Mm-hmm. Or an editor.
Or an editor. Visual Studio Code has lots of really nice plugins for Python, right? Yeah.
Yeah. I mean, do you consider Visual Studio Code an IDE or an editor at this point?
I don't know. It's a good question. It's certainly not as full featured as like PyCharm, but it has a lot of IDE functionality, I would say. But people would argue the same thing with Vim. I mean, Vim has all kinds of plugins for Python and just for code development more generally.
Yeah, but Todd's spot on though, like he always is. He always has great things to say. But the editor is such an underrated thing. But yeah, I mean, know your tools, right? I mean, if you're going to be an engineer, which I think is means you're also somewhat of a craftsperson, right? Like your tool is important. You get to know it. I moved to VS Code a while ago, and I love it to death. Before that, I was on Sublime, and I think before that, I was on Vim, and I still use Vim. But I don't know. I mean, VS Code works great too. So you can have Vim bindings in it if you want. What are some examples of? What are some typical examples of ETL that can be done for any personal project?
I mean, the reality is that with cloud data warehouses, you have access to quite a bit of processing power without spending a lot of money. So you can spin up, a Snowflake trial and just experiment with doing some basic data transformation and cleaning.
Oh, yeah. The big one that I forgot to mention was DBT.
Oh, yeah. DBT is a big one here. And
so this fits in with the...
Yep.
Yeah. How could you forget? It's only the one staring us in the face. So yeah, DBT. Typical examples of ETL, maybe. Okay, so personal project. I think it depends on what your personal project is. If it's a data warehousing project, you may want to consider doing stuff like slowly changing dimensions, for example, right? There's different types, go Google them. Setting up data pipelines into your data warehouse, right? But if it's I think it really depends on what your personal project is.
Yeah.
Any personal project that's kind of open-ended, so we'll give an open-ended answer. Typical examples of ETL. I mean, if you're kind of zooming it out a bit, though, right? If you look at extract, transform, load, things along the data engineering lifecycle. So it'd be like ingesting data, storing it, transforming it. So maybe some novel ways of transforming stuff. But again, I don't know what your personal project is. It's hard to make a blanket statement about like any personal project because that has as many answers as there are personal projects. So unless there's a way you can think of to like consolidate down the personal project, Matt.
I mean, you could just kind of beat your head against some of the very banal work the data engineers have to do. Like recently, we were working on a project to import idle loan data. So this was like emergency pandemic loans. And the government, the SBA has made a lot of this data public, but it's terribly formatted and it's a huge mess to get it imported into the data warehouse. If you want to get into the guts of what ETL is all about, then try importing that into Snowflake and BigQuery, for example, and getting it clean. It's not easy.
Oh, that sounds gross.
Yeah. but it's the kind of stuff that unfortunately we have to do. It's the maybe not as fun part of data engineering, but it's really critical at the same time to be able to take dirty data and actually make it useful.
Yeah, for sure. Well, cool. Anything else we want to talk about on this topic? Again, the question was, what software engineering skills should a data engineer have? So I think we hit on some. I think it's
a big topic.
It is a big topic. I know, and I think that to bring it back, engineering skills are actually the things that I think we are fond of saying that maybe there's skills data engineers should have. If you look at what's been done in software engineering, as we talked about, and as Todd mentioned too, what was that? Pragmatic programmer. I mean, none of this stuff is that new. It's just people are applying software engineering principles to data now, and they always have been actually as well. This isn't like data engineering is. I think it's a new term, but it's encompassing probably a lot of old practices, and by old I mean practices that were very traditionally done by ETL developers, maybe BI engineers. I could make an argument that ML engineering has some great overlap with data engineering, but that's also a new field. And so, but there's nothing really new under the sun. And pragmatic programmer is as good of a place as any to start kind of learning the fundamentals, just proper engineering as it relates to software. So, and anything else you want to add to this question?
Oh, I would just say when we talk about data engineering versus like ETL development, the reality is these aren't so much different practices as different cultures. That's really where you get this kind of these conflicting ideas. And if you really dig down, you find that there's a lot of commonality between the ideas, but these groups tend to speak different cultural language.
Yeah, for sure. Because
data engineering came out of places like Google and Yahoo with development of Hadoop, and then at the end of the day, as you've talked a lot about. They ended up converging with stuff that enterprises needed to do, like maintain data quality, metadata. And so they kind of we're converging between enterprises and the Silicon Valley-based data engineering, because ultimately the problems you need to solve are very similar, but we kind of need to speak each other's languages at some point to work more effectively together across these cultures.
Yeah, but I think the big difference too is implementing stuff again, like DevOps, data ops into the practice. Like this fundamentally means taking what used to be these monolithic, long-running jobs in Informatica or whatever tool you're using. These workflows were notorious for 36-hour data pipeline, and if it breaks anywhere in the pipeline, you got to restart it. So attempting to have more quickly deployable, quick iterations, continuous deployment type, and integration. Into your workflows. I think that's really where modern data engineering is sort of taking over. You're seeing, practices like analytics engineer and whatever other titles will be made up over the next few years. But principally, though, it means, it'll be like, in some sense, X as code, or if you're using managed service, quick iterations, quick deployments, and no single point of failure like you would have in the older data systems, which again, were notorious for just being very fragile for the most part, unless you're at a company like Google or Netflix back in the day that had to kind of make these systems by hand because there's nothing that off the shelf that would solve the problems, right? Yeah. So,
and I think the culture of data engineering and DevOps, modern software engineering practices, has a lot to teach more traditional silos of enterprises in corporate America about data. At the same time, they need to recognize things that they can learn. There is a lot to learn there, and I think the convergence of those two pieces of data that have kind of been siloed is really a big opportunity for everyone involved.
Yeah, exactly. Yeah. Awesome. Well, I think that's basically about it. So again, for people joining the show, after we started, Monday Morning Data Chat is moving to a live format, 9 a.m. Mountain Time on YouTube Live and LinkedIn Live. And if you like what you see, subscribe to our YouTube, Ternary Data, as well as you can find this episode on podcast hosts of your choice. And we look forward to seeing you all next Monday. So great questions, everyone out there.
Yeah, thanks for
Todd,
participating.
Jake, Snail. Who else are we missing out on here? Veet, Danny, everybody, thanks for your support, and we'll see you next week. So take care.
See you next week.
Bye-bye.